Chapter 6, Standards and Interoperability. We have skimmed the surface of interoperability a little bit in Chapter 2, but we will talk about it much more in depth in this chapter. You've learned that there isn't a single information system out there that can really provide all the functions for a safe, high quality, accurate, and efficient environment. There is not just one system. This means that multiple systems must work together or interoperate with one another to share the data. So interoperability is the ability of an information system to participate in a complex information management process harmoniously, that's the key word, with a number of other information systems. They can either operate by proprietary or IT standards. Proprietary interfaces are vendor-specific and are usually tightly controlled by the vendor. This means that they are usually expensive and also difficult to maintain. They are also usually confidential, which is great, and it makes them difficult to use and understand as well. IT standards define information system behavior in an open and understanding manner. In the United States, the American National Standards Institute coordinates standards development. The ANSI accredits the Standards Development Organizations, or the SDOs. Now, not to confuse you too much, going even further, the most important ANSI designated SDOs are HL7 and NEMA. NEMA stands for the National Electrical Manufacturers Association. HL7 is responsible for the development of itself, HL7, but NEMA is responsible for the DICOM standard. The book talks a little bit more in depth about these standards, and you can find that on page 82. Integrating the Health Enterprise, IHE. This was formed by the Radiological Society of North America, so RSNA, and as well as the Healthcare Information and Management Systems Society, or HIMSS. It is an international organization with a formalized process to develop technical frameworks that specify how standards shall be used in order to solve problems. IHE is organized into domains similar to how clinical enterprises are divided. So within a hospital, you may have cardiology, IT, lab, radiology, all separated, and it is similar with an IHE. Imaging informatics professionals, you'll see this abbreviation a lot, IIP. They must be familiar with common standards and technical frameworks that dominate medical imaging. And it is absolutely essential that IIPs stay current as their field evolves over time. Vendors must provide an integration statement if they claim that they are IHE compliant. You don't want to buy this awesome system that you think is going to work marvelously and then realize that it won't even integrate with your network, with the other systems on your network. Then that whole harmonious word goes out the window. Going even further, the vendor needs to specify which integration profiles they participate in. IHE integration statements are extremely important when you are looking for a new PACS system. On page 93 in your book, figure 6.4, you can find an IHE integration statement example. It's important to take a look at the categories that the vendor needs to have filled out in order to complete the statement. So I suggest you take a look at figure 6.4. All right, so don't let this slide fool you. It doesn't look like there's much on it. However, it is extremely important to know what network time protocol is and does. NTP is used to synchronize clocks in the computer system. So if you think at work how many clocks you have, there are actually hundreds just in your department, I'm sure. It's essential that all of these clocks are in sync with each other and line up with the same time. NTP is the internet standard, and it is absolutely critical that all the clocks are synchronized so that messages are interpreted in the appropriate time frame. A great example of this is when a radiologist dictates a report. When he actually does his dictation, he has to mention the time that he is dictating the report in with his dictation. If, let's say, he forgets to move his clock forward an hour during the spring forward time frame, then essentially his dictation time is completely wrong. Moving on to DICOM. This is another very important word that you need to be familiar with. DICOM is managed by the Medical and Imaging Technical Alliance, and it is an ASNI, remember that's the American National Standards Institute, ISO, an international organization for standardization, and a European standard for medical imaging. So if you want to relate DICOM with one word, it should be standardization. The DICOM standard is actually a document. It is actually a structured multi-part document. And the vendors, when they're selling their equipment, you need to make sure that if you're buying from them, that their system is DICOM compliant. In order to do this, they need to be able to show you a DICOM conformance statement. This just basically says, hey, my system is going to work very well with DICOM. Everything is going to line up and match up, and I am compliant with DICOM. Without DICOM compliance, there could be tons and tons of issues with a new system integrating with other systems that are already existing. So keep in mind when purchasing medical equipment that it is very important for the vendor to show DICOM conformance. DICOM application entities are systems that implement DICOM functionality. They have three things: titles that name them, an IP address that defines their network location, and a port number that defines the network port on which the entity is listening for DICOM communication. The information object definition, the IOD, is the data model of a real-world object. So each IOD is made up of modules that contain information about a particular information entity. An information entity represents a real-world entity. A DICOM data element. This is the smallest unit of information in a DICOM information object. Each DICOM data element has a tag that consists of a group number and an element number, and it's usually shown in a hexadecimal and in parentheses. So it's just laid out just like this. It has a value representation, which tells what kind of data it is, and value multiplicity, which specifies whether the element can contain multiple values, and if so, how many. DICOM data elements are stored in the DICOM IODs by group number first, and then by element number. An association negotiation, very important with DICOM communication. It defines certain parameters of how DICOM applications exchange information. So an association negotiation is critical to a successful DICOM communications. Both parties have to kind of shake hands and agree to the communication terms. If two devices don't have common association types as laid out in their conformance statement, they will not negotiate an agreement and the communication just won't work. Health Level 7, or HL7, it is an independent, not-for-profit organization, and it is an ASNI, Accredited Healthcare SDO, Standards Development Organization. The HL7 defines events that trigger flow of information between systems. So, for example, a patient is admitted, and that is considered a common trigger event, so it has a cascade effect. There are 123 message types that serve over 280 defined event types, just from that common event trigger. Each message is then identified by a 3-letter code that appears in the header of the message. There are 3 different types of messages. There are ADT messages that are related to patients, specifically admission, discharge, and transfer of patients within a facility. This is how the patient registration process is communicated through these types of messages. Then there are ORM messages, which are used to place orders and convey order status between systems. So, for example, a radiology exam order would be conveyed between the EMR and the RIS by an ORM message. Then there are ORU messages, which are used to convey the results of the orders.